Hi, I'm B from Nectar Mechanics, and welcome to part 2 of 3D printing my custom transforming Optimus Prime figure. So welcome back for part 2. Now, in the first video, if you missed it, we were doing the planning and sketching phase of the project, and I'll make sure to link that down below. In this video, I want to introduce you to 3D modeling and the different types of software and what they're good at and what they're not. And I'll also give you some tips that are specific to modeling transformers as well. Now, there is thousands of 3D modeling software out there available for you to just use, but they all use different methods from one another. So let me show you the main three. We've got surface mesh, parametric, and constructive solid geometry. These are all big nerdy mouthfuls, so let's break it down. You can think of surface mesh modeling as almost like origami. Each object's corners are called vertices. The line connecting two vertices is an edge, and if you have three or more, then we have a face, or polygon. Every single object is made up of either lots of triangles or squares, which lends itself well to organic shaped models. The more triangles, the smoother the object. And if you come across models online that are labeled low poly, that means they've got a low amount of polygons, which is why they often look quite spiky. Parametric modeling is a lot more like visual math. Each object is made via parameters rather than vertices, allowing you to update those parameters to have a model that's easily tweakable. Typically, objects made parametrically start off as a sketch. This is a 2D drawing of a side of your object. You could constrain the lines in this drawing to be more specific measurements, and then we can pad that sketch, stretching it into a 3D object. Everything we just did, the measurements, drawing the shape, the amount we stretched the object, that's all been saved in a list. If further along our modeling journey we realized we needed it to be 50mm tall and not 20, we just find the initial sketch in our list, tweak the number, and it all dominoes and updates the chain of actions. And now finally, we have constructive solid geometry, which, despite having the biggest name, is actually the simplest method out of all of them. You could think of this as modeling with cookie cutters or stamps. We use primitive objects like cubes, spheres, cones and whatnot to cut or merge with one another to create new shapes. While this looks a lot more basic than the other types of modeling software, you can still create really intricate models if you have enough patience. Now that we know the different types of modeling software, what's good for what task? Surface mesh I typically find best for more sort of arty models. Think cosplay helmets, or miniatures, cars, animals, anything with a slightly more curved organic shape. Having control of all of those vertices allows you to get shapes with a lot more of a flow to them. Parametric sketching, however, is great for precise models. Having control of all of those measurements so precisely is an invaluable tool. Not to mention it saves all the parameters on a list, so you can go and tweak it. If you're a messy modeler like me, it's very nice to be able to just go back, tweak it, and everything updates so it still works nicely. When it comes to constructive solid geometry, I don't typically use software that's dedicated to that anymore. Usually I'll use it as a method to use in conjunction with the others. You can cut objects with one another to make sure that they actually line up flush at the edge. For those interested in free software that allows you to try out all these different methods, I recommend Blender for surface mesh modeling, CAD for sketch-based parametric modeling, and Tinkercad for constructive solid geometry. So now that you know all the different types of 3D modeling software and how they work, what's next for the Optimus project? Well, it's time for the block model. What's a block model, though? Well, since Transformers figures are so complicated with all those different moving parts and whatnot, it's a lot easier to create a basic block model of the character with all the correct measurements and pinhole sizes and joints you'll want, but with none of the surface detail. We can 3D print those block prototypes a lot quicker, and it means that we can find problems a lot quicker as well. There's no point in doing a really nice detailed head sculpt if it turns out it doesn't even fit in truck mode, right? It's a waste of time. Now, since I'm going to be wanting precise models with all the correct measurements, FreeCAD's the way to go. So I'm going to boot it up and start converting those drawings I did in the last video into 3D models. Now, I don't intend to go into how to use FreeCAD in this video, as that would make this video much longer. But Mango Jelly on YouTube has already made some great tutorials, so instead I'll make sure to link him down in the video description below. I will, however, go over some tips I have for making specifically Transformers models in FreeCAD. The first and most obvious tip is only model one half. Unless your character is asymmetrical, you only need to model half the bot, and it's going to save you so much time in the long run. The second is to avoid shape binders. In FreeCAD, if you have multiple parts, you can use a shape binder to reference a separate piece in your sketch. This means you can get parts lining up with each other, and you'd think that would be great for a Transformers design. More often than not though, when I'm in this early block model phase and I'm being quite quick and rough with my modeling, the tweaks I make to the part that's being referenced often break the binded one, and I end up having to rebuild or fix my other pieces. So instead, I use the orthographic camera to line up my pieces manually. It sounds a lot more time consuming, and I'm not saying it's the best method, but it means that none of my objects are balanced on each other like a house of cards. Now, when designing a Transformers toy, you're often going to want to move the pieces back and forth to, check everything still lines up. But doing that manually over and over, it's just not practical. Instead, I create groups with links. You can think of these as like clones of the original part, which you can move into the alternate mode configuration somewhere else in your scene. Whenever you make a tweak to the original, you're able to see in real time how that's going to affect the alt mode, and if it all still fits. In part 1, I went over different joint examples, and I want to share with you what joints I find best for what task in a printed figure. For the hips of a figure, I always try to use universal joints where I can. Even though they will up the parts count a ton, they're much better at holding the weight of a figure than printed ball joints. Ball joints are, however, great for heads, hands, and other non-major load-bearing pieces. When I use them for heads, I like to do the single-piece socket design like Marvel Legends figures, rather than a two-part clasp. But if you get it wrong, your head is always going to want to fall off. I've found from lots of testing that the best way to model a ball socket like that is to get a sphere, Boolean cut it just below halfway, stretch the bottom so it's almost a cylinder with a spherical top, and then use that to Boolean into your head cube. From there, I'll also make the ball slightly bigger than the socket, and continue making it bigger or smaller depending on the results of my test prints. You probably noticed that I swapped to Blender for those Boolean cuts. FreeCAD is fully capable of doing Boolean cuts itself, but because it's trying to keep everything parametric and all in that nice list, sometimes it gets in a bit of a fight with itself. Blender, however, doesn't care. With pin swivels in my prints, while I did use filament pins for my seekers, so you didn't need to buy any additional materials, I found that they do not stand the test of time as well as I'd like. Instead, I now use 1mm diameter metal pins. They're much stronger, and the small size is a lot nicer to work with. Since 3D printers struggle to print round things, something I'll dive into more in my next video, I found that making a pinhole size of about 1.3mm in diameter instead of just the 1 is a lot better overall. Depending on the orientation of the print, this can either be a perfect fit, a little loose, but after all my testing, I did find this was the best compromise, as anything smaller would be too tight a fit. And my final specifically Transformers modeling tip? Don't be afraid to use sliding joints. See, for the past few years, official toy designers from Hasbro have been allowed to share more of the behind-the-scenes process on making Transformers figures, which has led to a lot of toy collectors becoming backseat modelers. You see, an awful lot of the interviews and whatnot have explained that they don't use sliding joints anymore because they can wear down quicker and they also are more difficult to assemble in the factory. This is true and definitely applicable to injection molded figures that you need to produce en masse. But the same rules do not apply to you when you're just 3D printing a fun little one-off figure. People end up trying to berate other modelers because, ooh, sliders is easy and cheating. It's not. Printed sliders can be perfectly strong, as long as you use metal pins and make sure to give a decent amount of tolerance gap, then the parts can't get stuck, they can't get broken, and the only thing you might find is that they get loose over time. And in that instance, a little bit of super glue on the inside, flick it back and forth, and you're golden. Now before I finish this video off, the biggest tip I can give you is don't feel like you need to be locked into a single CAD program. See, just because I can use a screwdriver as a hammer doesn't mean I should. It's not as good as an actual hammer. And the same analogy applies to 3D modeling software. FreeCAD is amazing for doing stuff like the block models. Doing anything that looks organic or nicely sculpted, however, is very tricky. You can still do it, but it's very tricky. Blender, however, is a lot better at that side of stuff, but kinda sucks at getting precise measurements. Again, with the right add-ons and software, you can give Blender those measurements, but it takes a lot more finessing. Honestly, the best thing you can do is to just figure out the basics of a variety of these softwares, find the ones that you like, and then use them in conjunction with each other. So, I hope you found this video useful. In the next video, we're going to be going over rapid prototyping and actually 3D printing these models. If you have any questions about that process, make sure to write them in the comments down below now so that I can read it before I record the next video. That way, I can answer your questions in that video right there and then. Otherwise, if you liked what you saw and you want to see more, feel free to subscribe, and I'll catch you next time. Farewell!